Chapter 3, Sample Problem 4. Shown at left are vectors labeled k, l, m, and n with lengths in arbitrary units superimposed on a grid. On the grid on the right, construct a graphical representation of j, where j is the sum of k, l, m, and n, with labels for each vector and indicate the direction of j. I'm going to give them their own color instead of labeling them. So let's say that k is purple, and L is red, and M is blue, and N is orange. So we pick one of them. I'm going to pick K because why not? And we transpose it over here and say that K is 3 vectors due north. I'm going to add L, and when I add a vector, the easiest thing is to start here and then move over so as to produce a parallel vector. So I will go over 2 and down 3, so L goes like this. And then I'll add M, and M will start where L ended, and I'll go over 2 and down 2. And then N will start where M ended and just go over 2. And what that gives me, when I want to sum them, is I start at my available endpoint and I go to my available arrowhead. So like that. And J is that one, which we can see is direction more or less David. What we could do is see, doesn't matter what order we add them in. So I'm going to add them in reverse order now. I'm going to start with N, and then I'm going to add M to that, which is 2 down and 2 over. And then I'm going to add L to that, which is 2 down, 3 down, and 2 over the other way. That was pretty bad though. Like that. And I'm going to add K in the end. So that goes up 3. And once again, I'm going to start from my available end to my available arrowhead. And I'm going to get, oh, look at that, the same direction D. It doesn't matter what order we put our vectors in.